that which is approved by the Army. In the report of the test I cited, in that document, it recommended that the curves for the altitude, position error for the clean, as well as the high drag external storage support system be included in the flight manual, but it ultimately was not included in the approved version.
Thank you. So, Mr. Bradham, Mr. Cooper was just saying about how the flight manual discusses the differences for the clean configuration helicopter, but it didn't make it into the Army flight manual, the differences for the ESSS system.
I'm sorry, just clarification, both altitude errors
Both
are not
sets
in the
of
file.
altitude
Yeah,
errors,
just
sorry.
for clarification.
Do we believe that crews should be informed of this difference?
So for the external storage support system for ESSS, yeah, that level of position error between 80 knots and 100 knots of about 40 to 50 feet, that level of position error was identified, you know, in the original qualification of the system. We verified that level of error exists through the L. We've looked for records of the discussion. At the time, there would have been an operator's manual content review board, and we've looked for a record of the discussion about altitude. We've not found a record of a discussion about whether, you know, about a decision to include or exclude that information. I think it's important to put that information in context when you're thinking about what to provide to an aviator in their manual, right? So that particular error has no influence on performance planning. And you got to put the size of that error in context. So we're talking about something that's 15 to 25 feet above the spec. And, you know, in my experience, typical aircraft separation distances are 500 feet or more. So it would be, I'd be speculating if I went to the reason of why they made a decision not to put that information in the manual. But it's, we've looked for that and not found that record.
Okay, thank you.
Thank you.
Now that it's been identified, do you plan on including it?
I say we've been tasked by the program, that the Airworthiness Authority has been tasked by the Program Office for Utility Helicopters to do the analysis, which we've done, and to provide a recommendation back, which is being done right now, which will then go to the PM office for their consideration as to how to whether and how to incorporate it into the manual.
Thank you.
Thank you.
Mr. Bradham, do you have the time frame for when that will be completed?
No, I can't speak to the program office in terms of the timeline. We've been.
Steve, or Mr. Bradham, I can speak to that. I'm the Division Chief of the Utility Helicopter Programs Office. I was the one who tasked Mr. Bradham's organization to take a look at this issue. And so typically we have a 30-day turnaround on tasks to the organization. We're about week 2 of that. And that's about the time we found out about this issue. And so we should have something back this fall at the latest. And we'd be happy to keep you appraised of that status.
Thank you. And I also ask that you bring your mic closer to you. Thank you.
Will do.
All right, Ms. Lewis. During our investigation, we saw the 80 to 130 foot differences between the barometric altimeters and then the radio and the geometric altitudes. Would you, as a pilot, consider this amount of difference impactful to your operation?
In my experience, a difference in 80 feet or so between the radar altitude and the barometric altitude would not be cause for alarm. Generally, I'm relying more heavily on one altitude instrument versus the other, depending on what I'm doing and what altitude I'm at. So I'm generally not looking at both and trying to figure out the difference between the two, depending on what I'm doing on that particular flight.
All right, this is for Mr. Cooper, Bradham, and Rosengren, just to start. But during the ground testing of the 12th Battalion helicopters, 2 of the helicopters, the barometric altimeters were within 20 feet of tolerance. But once we were in forward flight, with 100 knots of forward speed, the barometric altimeters showed errors of 80 to 130 feet. What types of errors do you believe could contribute to this 80 to 130 foot discrepancy?
Yeah, I'll start with that one, please. So when you think about all the different errors that could contribute to that, one, you have to make sure the Colesman window is clearly set correctly, and that the Colesman window actually reflects the right barometric pressure. So the flight tests you're referring to are the ones on the 15th of May, that 1 unit flight. So backing up, it's important to point out that that's really an anecdotal event. It doesn't use the standard flight test methods that the military and the FAA would use in order to characterize a pedostatic system. So there's not an independent truth measurement of barometric pressure and some of the other things that we would use here. But so in terms of the errors, one is the Colesman window. Then you have the instrument error, which is what you saw on the ground. All three of those aircraft were registering altimeter low on the ground, but within spec, right, for the instrument error. Then you have the position error. So 2 of the aircraft were clean, and 1 of the aircraft was ESSS. So the clean aircraft at 100 knots, you're looking at about roughly 7 feet altimeter low and position error. For the ESSS aircraft, about 50 feet position altimeter low for position error. And then you also have to correct for non-standard temperature, because you're trying to compare radar altimeter to barometric altimeter. And so that wasn't a factor for the accident aircraft because the conditions were close to standard and you were low altitude. But on the 15th of May, those flights, you were flying at about 1,000 feet and about 9 degrees hotter than standard based on the aircraft OAT. That's about 36 feet altimeter low. So the combination of those factors, the instrument error, the position error, and a temperature correction, which all happen to be in the same direction, doesn't always happen that way, but in this particular case did, that if you carry that for the 3 aircraft, those errors ends up bringing you to relatively good agreement between rat out and bear out, if you compare them that way.
Thank you.
And I concur with all the statements that were made. Just one clarification, because I was involved in that ground evaluation. One of the aircraft, the right altimeter, did fall outside the Army maintenance manual check limit, so that was out of spec, and in fact, its vibrator was inoperative. So that right altimeter data would be in question for that aircraft.
Thank you. Mr. Rosengren, do you have anything to add?
No, I just, the only comment I have there is whenever Mr. Bradham and I kind of went through the data pursuant to some of the questions I think we'll have later, I was properly educated and pleasantly surprised. We was able to get to doing the air stack ups within 1 foot of the differences, and so we'd be happy to provide that data to you in writing later.
We would definitely appreciate that. Thank you.
Yes, ma'am.
So continuing on that, and you were talking about how it is anecdotal, and we do recognize that 3 helicopters is quite a small data, it's a very small sample set, but it did line up with the existence of a possible wider discrepancy. And you have looked into that, clearly. Is there additional testing planned between the Army and Sikorsky?
So from an airworthiness perspective, we've gone back through the data, and we have airspeed calibration data for the Lima. We understand the static position error. So we don't have any flight testing planned. I'd leave that to the program office if they have other thoughts relative to that.
Yeah, no, as I mentioned earlier, I was as initial receipt of the data from the flight test and adult flight test you mentioned, I wanted to look into it, and I asked Mr. Bradham's organization to please let's get together and try to understand what's going on here to see if there is an issue. And again, after stepping through all of the various sources of error, and again, it's a very piece part manner, everything was within specification minus the discrepancy we've tasked them to look into. And so I don't see any need from a safety or airworthiness perspective to do any changes for the Lima helicopter. From my perspective, I advise the colonel who advises the Army the safety of the aircraft. My perspective is this is a safe aircraft.
Yeah, and we can, if you'd like, we can talk to the difference between the recorded pressure altitude in the recorder. Yeah. Oh, cool. Thank you.
So this conversation makes me conclude that this feels like this is an inherent limitation of a barometric altimeter.
That based on all the information we've worked together and along with our Sikorsky friends, I believe this is the expected errors in an altimeter system. So when we provide that data to an aircrew, there should be an expectation, as I believe they're trained to have that expectation, plus minus 100 feet or so.
Thank you very much. This is the end of my line of questioning, and Mr. Payne will begin next.
Get my microphone positioned here. Hello. I'm going to follow on with specifically pilot operational considerations, and we talked a bit more about stacking errors, and we touched upon setting the Colesman window correctly. I'm going to come back to that. So I'll start with Ms. Lewis, and I'll have some questions for Mr. Bradham also later, as he's an experienced Black Hawk pilot, it's my understanding. Ms. Lewis, earlier you described briefly setting the altimeter or your operations around that area. As a pilot, can you walk us through in detail the process of setting the altimeter according to the Army's operational procedures?
Yes, as part of the cockpit equipment checks, the barometric altimeters are set generally based off of the local ATIS information, and then it's compared to the known field elevation. And as long as there's not more than a 70-foot error, then the altimeter is considered reliable for flight.
Sure. I want to get into a bit of a discussion about the known field elevation. So you cross-check, obviously. Once you've set the altimeter according to the ATIS, there's a 70-foot allowance. My next question goes into, how do you determine the field elevation for those who are unfamiliar in the audience? Where do you get that data from?
Field elevation is published on airport diagrams. It's published on approach place. It's published in a number of places for airports that we operate in and out of.
Sure, for operational airports. So continuing on with maybe where your unit was based, is it tribal knowledge or an official part of Army procedures to discuss if there's changes in elevation between where the measurement is taken, which for FAA airports typically at the highest point on the runway, if you're starting or performing that check, as you said, prior to rotors turning, are you do the Army's procedures account for a difference in the airport topography when you make that check and try to fall within the 70 feet?
The Army procedure is to check tower setting against the setting for field elevation, and that it's unreliable for flight if more than 70-foot error exists.
Sure. Okay. Can you recall a circumstance where the published field elevation varied significantly from where you initiated the checklist procedure in your career?
As part of the checklist procedure, we don't attempt to determine if the elevation is different based on where the aircraft is parked. We base it off of the field elevation.
Okay. I'm just going to get, we talked about field elevation being published at FAA or, some kind of, whether in another country there's published data available. What if you're at a remote or unfamiliar airfield, you're operating there? Is there another resource you might use other than published chart, or would you rely on the topography of the chart itself in that situation?
I would rely on the known field elevation if there was one for where I was landing and taking off from. And in my experience, I would have generally departed from somewhere where I had an altimeter setting And if I did not know what the field elevation was or was unable to determine it, I would maintain that altimeter setting until I was back in location to receive an updated altimeter setting.
Okay, noted. Yeah, I'm just trying to approach the situation from as many angles as possible. When you're flying in the national airspace system versus flying on deployment outside of the national airspace system, for example, do these procedures change at all, or there's more emphasis done in the NAS versus on deployment, or does it remain the same?
There's no difference in how we approach setting altimeters when we're operating in the national airspace system versus on a deployment.
Okay, thank you. I'm going to incorporate Mr. Bradham into this line of questioning as well, so I just want to totally lean on Mrs. Lewis. So Mr. Bradham, during flight, how would a pilot determine the barometric altimeter is erroneous and unreliable?
Yeah, so in my experience, the only time we've done that in flight right on the ground check, if you had a significant difference, between the right and the left side in the ground check before you took off. And I want to point out that ground check exists. The FAA uses that same, in the Airman Information Manual, uses a similar check with plus or minus 75 feet. But yes, and in flight again, if there was a significant disparity between the right and left side while you were flying, and I mean a significant disparity, more than 70, 80 feet, right? You would make note of that and come back. But if ATC contacted the aircraft and said, "Hey, you're not at your right altitude," and we were, according to our instruments, that then would be cause for concern. But otherwise, and I've, in my experience, I'm trying to recall if that's ever happened to me where I've had a barometric altimeter problem like that, and I don't recall one.
Okay. Yeah, Ms. Lewis, you previously mentioned being queried by ATC. Have you ever experienced that in your career, or thought to a situation where you might want to question whether or not the left and right side altimeters were comparable?
I have not had an experience in my career flying the Black Hawk where the barometric altimeter, if it passed the checks on the ground, was unreliable.
Okay, thank you. Let's say hypothetically you had a crew and the two pilots did detect an offset between the right and left baro altimeters. I'll start with Ms. Lewis. What would they do? And then as a follow-up, would there be anything in the Army's operational procedures that would require the pilots to make a report or report it to maintenance?
If there was a discrepancy between the left and the right pilot's altimeter, are you asking which altimeter we would use?
Well, no, not which one you would use, but you've detected this discrepancy. It's more than 70 feet. Is there a requirement to report that then to maintenance, your command, make a note of it somewhere?
Yes, if there was a greater than 70-foot difference, that aircraft would not be flown. It would be placed on a grounding red X condition and be taken out of service until the altitude discrepancy was addressed.
Okay. I'm going to come back to this question, and you touched on it previously, but you said you preferred a different altimeter for different type of operation, different flight regime. In Army procedures, is there ever an operational area where you would cross-check between the barometric altimeter and the radar altimeter?
In my experience, in a situation where I was flying close to the ground, maybe 500 feet and below, if I was supposed to be at an MSL altitude, but I was flying low to the ground, in my experience, I would be referencing or cross-checking both instruments in that situation.
Okay. I understand it would be difficult because it would depend on where you're operating. If you're over sea level, obviously that calculation's much easier. Going through my questions and ones that have been answered essentially without me having to ask. Thank you. Getting more into a bit of an acuity discussion. It's discussed in our internal investigation. If you're flying in visual conditions during the day, what would the altitude visually that the pilot could recognize, would 100 feet difference be something that pilots are trained to know visually without reference to any instruments versus maybe 1,000 feet? Mr. Bradham or Ms. Lewis can take that.
Yeah, I'll give my experience.
Yeah.
And when you're very low to the ground, that's true, right? To be able to tell the difference between 100 feet and 200 feet, I would say yes. But, at a much higher altitude than, the difference between 4,000 feet and 4,100 feet, no.
Right. Yeah, exactly. If you're at higher altitude, also you can maybe tell difference of thousands versus lower. Let's see. Would this change at night? If you were, low-level flight, you say, I can tell the difference between 100 and 200 feet at night. Would you expect that calculation to be the same? I'll ask Ms. Lewis.
It's always more difficult to determine your altitude when flying at night, but I agree with what Mr. Bradham said, that if you're very low level, 200 feet and below, it's a little bit easier to determine, but even at 1,000 feet, 100 feet of difference is not something that in my experience, that I'd be able to accurately determine.
Sure, and then a quick follow-up there. If you're wearing night vision goggles, I guess, can you expand on the possibility of doing that under NVG at low level?
NVG's low level, if I have, it would help if there were known obstacles that I knew the height of as I was flying in the area out to the left and right of the aircraft. It really depends on what environment I'm flying in, what obstacles are there, buildings. It would really just depend on where you were flying out, how easy it was to determine a difference in 100 feet of altitude when looking outside the aircraft.
Okay. Yeah. Yeah, go ahead.
Just to follow up on Mr. Payne's question, for both Mrs. Lewis and Mr. Bradham, if you were flying in day visual conditions, could you notice a difference between flying at 200 feet versus 300 feet?
That's a difficult question to answer. From my experience, I would have to say that would depend very much on the terrain that was around and how familiar I was with that terrain.
I would agree with that statement. It would depend on where I was flying, and as I mentioned previously, if I knew the height of some of the obstacles or perhaps building or terrain in the area.
So to clarify, if you were not familiar with the terrain that you were flying through, then what does the answer change?
Can you just restate the question once just to make sure
If you're not familiar with the terrain you're flying through, could you pick up on a difference visually looking out the window between flying at 200 feet versus 300 feet? Is there enough of a difference at those altitudes?
Yeah, that's a difficult question to answer. I'm not sure if you'd be able to resolve that difference.
I agree. I don't know that I could 100% accurately determine the difference in altitude.
And my question was for day, so just to confirm my understanding, at night and under NVGs, it would be even more difficult to make that distinction?
Yes.
Thank you.
That was my kind of operations-related section. I'm going to shift gears slightly for my last few to Mr. Cooper, discussing some differences between the Mike and Lima model. So, Mr. Cooper, please describe the pedostatic system design on the Mike model.
Do you want to explain what the Mike model is
So-
versus Lima?
Sorry, for the audience, the Mike model would be a newer version of the helicopter. If you want to just expand on that rather than me explain why don't we just talk about the differences as well?
Again, it has its own set of requirements, to their vehicle, different engines, different, more capable rotor blades. So, but from an air data system, it utilizes the same pedostatic probes in the same location as the Lima. That is unchanged. It employs air data computers, ADCs. There is less plumbing because there are no, I will call them analog instruments equivalent to what is in the Alpha or Lima. So those probes feed directly, they feed the air data computers. The air data computers feed multi-function displays with digital data. And then those same ADCs through a redundant path provides air data information to the flight controls or any other subsystems within the aircraft which needs that information. There are 2 ADCs. Each go to their respective pedo probe, and the static, just as with the Alpha and Lima, is crossed. So there's the redundancy there.
Okay, so in summary, you've replaced, you said, well, older analog digital systems, there's less tubing because you have 2 ADCs and a glass panel display. I guess my ultimate question would be, given the differences between the Lima and the mic, would you expect more accuracy out of the mic versus the Lima in terms of displayed altitude?
Again, we talked about static source error and instrument error. I would expect improved accuracy for the instrument error aspect. The static source error is not changed.
Thank you. I'm going to pass the microphone over to Michael Portman, aerospace engineer from the Flight Recorders Lab. He's going to discuss air data accuracy for flight recorders.
Thank you very much. All right, good morning. So yes, as Mr. Payne mentioned, I'm going to start my questions with some design requirement questions for flight recorders. So I'll start with Mr. Gant on the civil side. What requirements exist for flight recorders in civil helicopters?
So for flight data recorders, there's a requirement in Part 91, which are the general operating rules, that if you are operating a multi-engine turbine-powered helicopter with a seating or passenger capacity of 10 or more, you must have a flight data recorder that records the parameters that are contained in an appendix. I think it's Appendix E, but of Part 91 that lists all the parameters as well as the accuracy requirements for those parameters.
Okay, and that was for Part 91. Are there equivalents in other operating parts as well?
Yeah, Part 135 has a very similar requirement for, again, multi-engine turbine air-powered helicopters with 10 or more passenger seating capacity. There's another break if you have a helicopter that carries 20 or more. There's a different FDR requirement, but still one.
Okay. Can you expand for a moment on, you mentioned that included in these appendices, there's also standards for accuracy of the data. Can you expand on that a little bit, specifically if you know anything about the altitude data?
Yeah, I think in the Part 91 Appendix E, I'll say the standards as I read them are fairly loose. I mean, for accuracy for the altimeter, I think it reads from anywhere from plus or minus 100 to up to plus or minus 750 feet with a resolution of, I can't remember, either 130 feet or 150 feet on readout.
Thank you. One more question for you, Mr. Gant. What methods does the FAA require to ensure the continued accuracy of recorded flight data?
Yeah, so there's no specific rule that says how often you need to be, I'll say, interrogating a installed FDR to see if it's still providing realistic data. However, in the technical standard order, as well as in our advisory material, it is incumbent upon either the manufacturer, the FDR, or the installer to come up with a maintenance program. And then our recommendation in the advisory material and AC 21-141B is that a reasonableness check for the FDR should not exceed being done beyond 18 months.
Okay, thank you very much. Turning to Mr. Rosengren. So looking at the design of the flight recorder system on the UH-60L, it's my understanding that the system was added after the initial production of the UH-60L. Can you just explain a little bit about when that occurred and what the motivation was for installing that system?
Yes, sir. So it was we call it a commercial off-the-shelf or COTS solution that we bought for the Integrated Vehicle Health Monitoring System, IVHMS. It included both a health and usage monitoring system, so a PCMCA card that a data card. I can't tell you what PCMCA stands for. A data card that you could pull out and download the parametric data that's also sent to the flight data recorder that we used for accident investigation, such as this. And so that IVHMS, the Integrated Vehicle Health Monitoring System, produces COTS. It was around the mid-2000s. So in 2005 and 6 is when we flight tested the COTS solution that we integrated as a government MWO modification work order. So that's how we installed the system onto the aircraft. We consulted with our Sikorsky friends, but it was with our Goodrich partner who we purchased the system from COTS, a commercial off-the-shelf, and then we got the installation instructions, the modification work order to put the aircraft on after the flight test and began fielding it in 2007.
Okay. And what design factors does the Army consider for the installation of flight recorders on helicopters?
So first of all, it needs to be airworthy, and we asked Mr. Bradham's organization to make sure it was airworthy from a component avionics perspective as well as a software perspective. So MIL Standard 810 and DO 178 were considered to make sure that the hardware and software were airworthy. And so when we did the modification work order, we got an airworthiness release from the Airworthiness Authority of the Army to make sure that modification work order to install the Integrated Vehicle Health Monitoring System was airworthy before we went through the installation.
Okay, and then I'll follow up specifically on the parametric data side of things. Did you have any standards or ideas that you had for what sort of things you wanted to be recorded, or what accuracy you wanted those things to be recorded with?
So the main reason we were putting the system on was twofold. It was for the health and usage monitoring system, which as the gentleman referred to, is our maintenance program that we use. So we download those parametric data after each flight or weekly, and we take a look at the data, make sure it mainly there for regime recognition. So by regime recognition, that's where we try to determine how the aircraft was flown, so that if we have any particular parts lives that are depending on how aggressive or non-aggressive you fly the aircraft is dependent, then we can determine that from the parametric data that regime was in, and then we can decrement the parts lives appropriately.
Thank you. Next question. Which standards, or are there standards that exist that the Army uses or requires for the accuracy of the recorded flight data on the UH-60L?
So we had a digital source collector operation requirements document back from 1996. We have to provide that if we haven't done that already. And in that standard, it was encouraged to have a commercial off-the-shelf solution, for which we did. So we didn't give the vendor we bought the commercial off-the-shelf solution from a data accuracy requirement. We did make sure that since it was commercial off-the-shelf, we made sure that it met the airworthiness requirements, but that it was capable to do the health and usage monitoring system requirement, as well as the flight data recorder function.
Thank you. Can you describe how the Army verifies the function and accuracy of the flight recorder upon installation?
Yeah, so at the end of the modification work order, there's a maintenance test flight that's performed. And as that maintenance test flight is performed, we have a maintenance operations check and MOC. And in that MOC, we record what the displayed altitude or other parametric parameters are select, not all, but a select some. I'd be happy to provide that table to you. And then we record what was recorded in the parametric data.
All right, and then a follow-up to that. Can you describe similar thing, how the Army ensures the continued function and accuracy of the flight recorder in operation?
Sure. So as I mentioned, each time the particular installation has occurred, we do those maintenance test flights and we do the MOCs to make sure that the installation was successful. As we improve the system over time, we went through a substantial upgrade back in 2008, where the original 2005 system did not have an integrated flight data recorder. So the 2008 version, we put the integrated flight data recorder, of which we have the configuration today. We've had several software upgrades. During each software upgrade, they do a system integration lab test at the factory to make sure that the software performs as designed. And then we go through a similar airworthiness analysis of the MWO with the updated software. And then that MWO is then updated. And again, each time it's installed, we do the maintenance test flight and then do the maintenance operation check at the end to make sure that the data is correct.
And just to clarify, are there any requirements for downloads at certain times specifically to verify the function and accuracy of the recorded data itself?
So we download the data at the end of each flight. It's available for download and put into our data warehouse that we monitor through artificial intelligence and other means to make sure that the data is reasonable. And so that's performed on a regular basis.
And is that specifically for you mentioned for doing, usage and vibration analysis and whatnot. Is that specifically for that, or is it to look at a broad spectrum of parameters?
Yeah, there's 3 specific parameters we look at. I can get to those particular parts, but there's 3 specific parameters we look at to make sure that the vibration data is not over any exceedances. And if those particular parameters are over exceedances, then we do an on-condition change to those parts.
All right, thank you. Moving on to some operational questions, although I am going to stick with you, Mr. Rosengren.
Yes,
how is the flight recorder data used within the Army? I know you'd mentioned that it's mostly used for this vibration analysis. Is there any other example of, or any times that you can think of where download of the FDR data or the flight recorder data of any type has been performed for reasons other than those you had mentioned?
In the operational Army, there has been programs over the years where we try to do a flight operations quality assurance type of effort. So those efforts have been done where we've used the downloaded data to do flight recreations, mission rehearsals, those sorts of things. But that never got out to the operational Army.
Okay. Can you describe how the data is downloaded?
Sure, there's the data card that gets pulled out of the system, and then that's taken to an aircraft notebook, a laptop computer, and you install input into the laptop computer, and then there's a procedure to extract the files and get it into the cloud-based system where we store our data.
Another question for you. When looking through the data, we did notice that that there is no GPS, global positioning system data that is recorded on the flight recorder. Can you just explain why that is?
Yeah, as was mentioned before, the 60 Liam is an analog aircraft, and so when we did the modification work order and the installation to put the system on the aircraft, we got the signals that were available, and those signals were not available for incorporation into the integrated vehicle health monitoring system.
Thank you. One last question as I'm wrapping up, this time for Mrs. Lewis. On the UH-60L, the air data transducer provides pressure altitude information to the heads-up display. I'm curious, in your experience, have you ever done a cross-check while using the heads-up display between that altitude and the altitude that's in the barometric altimeter?
Sir, in my experience, using the heads-up display would be for low-level flight under night vision goggles, and I would not be referencing barometric altitude in my heads-up display.
All right, thank you very much. I'll turn it back over to Mr. Shin.
Mr. Fuchs, can you pull up Exhibit 7 Kilo Juliet, page 23? for the witnesses, that's the presentation backup slides that has the diagram for the right barometric altimeter and the uncorrected pressure altitude that it feeds to the helicopter's transponder for the UH-60L, and how that pressure altitude data gets transmitted to ATC ground radar and also out to ADSB. So, Mr. Bradham, on this on the UH-60L, if the right barometric altimeter provided inaccurate altitude indications, regardless of the source of the error, would the transponder transmit that inaccurate pressure altitude through the to ground stations?
Yeah, so the transponder on the right side has an encoder, and the encoder sends a signal in 100-foot increments, and that signal is based on pressure altitude, so it's referenced to 2992 as the Colesman window. So if the pilot made a mistake and put the wrong Colesman window setting in, or the setting was not indicative of the true static pressure, that error would not be transmitted. But any other errors in the system would be transmitted, but the encoder is transmitted in, you know, it's only in 100-foot increments. So, yeah, cool. Thank you.
And Mrs. Lewis, are there, for the UH-60L, are there procedures for what pilots should do with the transponder's functions if they detect that the right barometric altimeter has become unreliable during flight?
For the UH-60 Lima, the transponder is required for flight. So if there was an issue with the transponder, the aircraft would return to whatever station it departed from, and that issue would be addressed before flight was continued with that aircraft.
I'm sorry, if I may, could I just add one point, that the encoder, it's sending in 100-foot increments. It changes at the 50-foot mark, but the standard is 50 at the 50-foot mark plus or minus 40 feet. So it can be 90 feet off inside its specification. Thank you.
And Mrs. Lewis, to clarify, if the right barometric altimeter was determined to be unreliable during the flight, knowing that it transmits its encoded altitude to the transponder, is there any procedures to disable the altitude reporting function on the transponder, or do you just leave it alone?
There's no published procedure for addressing that I'm aware of.
And would you notify ATC of the discrepancy that's identified if flying in the National Airspace System?
I would.
Mrs. Lewis, going back to one of the previous questions about cross-checking between the left and right altimeters, and this is a question that Mr. Bradham can answer as well. Is there a published procedure for pilots to cross-check between the left and right side for accuracy between the two altimeters?
The check is against field elevation. It's not between the two altimeters. So the 70-foot error, if field elevation was 0 feet, one could be 70 feet and the other one could show minus 70 feet. So it's not an error between, it's not checking for error between the two, it's the setting against field elevation.
Yeah, no, I concur.
And if there was a discrepancy between the left and right barometric altimeters identified during flight, let's say on the order of 100 feet, Mrs. Lewis, how would you verbalize that, or how would you triage that with the other pilot?
If there was a difference of around 100 feet, 100 feet, that's to maintain within 100 feet of altitude is the standard for us flying. So if it was right at about 100 feet, that would not give me much cause for alarm, because it would still be within the standard of maintaining altitude within plus or minus 100 feet.
Mr. Bradham, when you were saying the additional 40-foot change on the transponder altitude, do you have documentation of that you could provide?
So the encoder standards, it's mil-spec 81852, which was the mil spec for the altimeter. When you, in the encoder section, it says the standard is at the 50-foot mark plus or minus 40 feet from that. And yeah, so it's in Mil A 81852, it's paragraph 356, and under encoder it said the switching point shall be at altitudes 50 feet plus or minus 40 feet removed from the nominal indicated altitude.
Thank you very much.
Thank
And
you.
Michael Portman has another question.
Sorry to circle back. Just one last question for Mr. Gant. In Part 135, Appendix E, you had mentioned that there were standards for accuracy, in this case for altitude, that can vary between plus or minus 100 feet to plus or minus 700 feet. Can you clarify that those standards are plus or minus 100 feet that is recorded on the FDR as compared to what?
I would have to defer that question to get back with you folks.
Okay, thank you.
All right. Mr. Gant, the FAA has several restricted category UH-60L helicopters that are approved for civil use, including the Lima model. What are the static system and barometric altimeter design requirements for these restricted category helicopters?
So the FAA regulations for bringing in surplus military aircraft that have been designed and manufactured for use by the U.S. military, given a satisfactory operating history, which usually is at least 10 years, if they are surplus and they are determined to be airworthy by the FAA, they can come into the system utilizing, I'll say, the military records as well as military flight manuals. There will be no additional showing to the FAA to bring those aircraft and put them on the registry under restricted category. And under restricted category, that severely limits operations, mainly to agricultural, external load operations, and forest and wildlife management, which usually translates into firefighting operations.
Mrs. Lewis, can you just clarify for us, when flying low level, what would be the primary instrument you would reference for altitude?
The radar altimeter, in my experience.
And would that change when flying on a helicopter route with a ceiling?
If it's a published MSL route, I would still be referencing radar altitude, but I would also be taking barometric altitude into more consideration than what I normally would be if I was flying at a low altitude, if that makes sense.
Okay. And it is that so if I understand you correctly, you'd be referencing low altitude on a MSL route with a ceiling. You'd be referencing both the rad out and the barometric altimeter.
Yes.
And is that trained or is that a personal technique?
There's no standard for which instrument I would be looking at, but if I'm on an MSL route, I would have to be at some point referencing the barometric altitude to maintain the route altitude.
Okay, thank you. Yeah, my question I think really was, is that a procedure that's trained in the Army to cross-reference those two instruments, one on a route of that nature, or is that more of a personal technique for you?
I would say that's more of a personal experience-based technique for me, but also coming back to if I'm on a published MSL route, the only way for me to maintain the prescribed altitude for that route would be to utilize my barometric altimeter as well.
Understood. Thank you.
Chairman Hamady, that will complete the technical panel's questions.
Thank you very much. We're going to take a 15-minute break. We'll be back and start promptly at 11:35.